In this video, we will go over how to solve an equation in a single variable. Now remember, whenever we're solving equations, we are trying to rearrange the expression while still keeping each side equal to the other. An important thing to remember is that this equal sign, what it's stating is that whatever's on the left side is truly equal to the right side. So in this case, whatever x is, there is some value x, such that if you multiply it by 4, and then add 5 to it, your resulting number should be 29. So what we're going to do is we're going to solve for x by moving the expression around while still keeping both sides equal to each other. After we get our answer, we're going to check it by substituting it back into the original expression and seeing if we get a true statement. Let's begin. As we seek to solve and get x by itself, we want to get x as the only thing on its side of the expression. So we need to decide, should I move the 4 first, that's getting multiplied, or should I move the 5 first? While technically you could move either, one way is going to make it much more likely that you're going to get the correct answer, and that would be to move the 5 first. We want to move the things that are farthest away from the x on its side. 5 is currently being added, so if we subtract a 5 from both sides, 5 minus 5 goes to 0. Which would leave us only with the 4x on the left side. 29 minus 5 is 24. And what we see here is this is still an equivalent expression because what we did to one side, we have done to the other side. Now I've almost got x by itself. Now if I just divide both sides by 4, I would get that x is equal to 6. Now to check your work, you always plug it back into the original expression, so let's take 6 and plug it back in. 4 times 6 plus 5. 4 times 6 is 24, plus 5 is equal to 29. What was it supposed to be equal to? 29. 29 equals 29, and we get a true statement. So that's how we can know that our answer is correct. So the great thing about this section is you can always check your work and be confident if you got the correct answer. Let's continue with our next example. Our goal is still to solve for x, but as I look at the left side, I see that this is not fully simplified. So just like we learned in the last section how to simplify expressions, never start trying to solve an equation unless both sides are fully simplified. So before I can start trying to isolate the x, I need to distribute the 6 to both pieces here. And that would give me 6x minus 18 minus 10x equals negative 10, and now this left side can be simplified, specifically 6x minus 10x would collapse to just be a negative 4x minus 18 equals negative 10, and now that the left side is fully simplified, I can start to solve for x. So I'm going to focus on getting x by itself by moving things by doing the opposite operation. Okay, we need to decide, should we move the negative 4 first or the negative 18 first? Think about it for a second. In this case, we'll want to move the negative 18 first because it's quote-unquote farther away from x on its side. You always move addition or subtraction before you move multiplication or division. 18 is negative, so if we do the opposite of adding a positive 18, what that will do is it will completely cancel it from the left side because negative 18 plus 18 is 0. And that will leave us with just a negative 4x on the left. But we've done it to the other side to keep the expression equal. Negative 10 plus 18 is a positive 8. Negative 4x equals 8. So we will divide both sides by negative 4 because it's currently being multiplied, so we do the opposite. 8 divided by negative 4 is negative 2. Now we'll check our work. I'm going to plug negative 2 in for each x in the original expression, so 6 times negative 2 minus 3 minus 10 times negative 2. Let's see what that's equal to. That's equal to 6 times negative 5. 10 times negative 2 is negative 20, minus a negative would become a positive 20. Negative 30 plus 20 equals 10. What was it supposed to be equal to? Oh, sorry, that should be a negative 10. Negative 30 plus negative 20, or plus 20. and it was supposed to equal negative 10. So that means we did get the right answer. Now, as we look at our next expression, I take a look on both sides and I say, oh, there's an x term here, and there's an x term here. So I've got multiple x terms on each side. What you would do in that case is we need to move all the x's to one side, all the numbers to the other. Now, it makes sense that we can move the 2x over by subtracting a 2x, or we could move the 8x over by subtracting an 8x. But if we subtracted 8x from 2x, we would get negative x's, so although you can move either direction, generally move the one that would result in a positive final answer. So I'm going to move the 2x over. It's currently positive, so I'm going to subtract 2x from both sides. And that would cancel. I'd just be left with 9 on the left. 8x minus 2x is 6x's. Minus 3, and at this point it just becomes one of our normal problems. We isolate x. I recommend you pause the video right now and solve for x. Unpause to check your work. Now in this case we will get the x by itself, so I need to move the 6 and the 3. Currently I'm subtracting the 3, so I'll move that first. It's negative, so I will do the opposite and add 3 to both sides. 9 plus 3 gives me 12, and I only had a 6x on the other side. 6 is currently being multiplied by x, so to move it to the other side, I'll do the opposite, and I'll divide both sides by 6. That cancels it here, and we're just left with x equals 2, or written in the order that we generally prefer, x equals 2 here. Now we'll check our work. Take a moment to check the work. Pause the video and check. Unpause to verify your answer. So we had 2 times 2 plus 9. Is that equal to 8 times 2 minus 3? We'll simplify each side and see if they're equal. 2 times 2 is 4. Plus 9, is that equal to 8 times 2 is 16 minus 3? Let's see. 4 plus 9 is 13. 16 minus 3 is 13. These are indeed equal, which means we did get the right answer, because when we plug in the answer of 2, we get two equations that are equal to each other as expected. Now for our next expression, as we look at the left and the right side, we see that they're both not fully simplified. So I recommend you simplify the left side separately and the right side separately first. For the left, I need to distribute the 4. For the right, I need to distribute this and combine like terms. Take a moment to pause the video and just do the simplification step on the left and the right, and then unpause to check your work, and then we'll continue solving the problem together. 4 times 2x would be 8x. 4 times 1 is a positive 4. That's supposed to be equal to 29 plus, 3 times 2x is 6x. 3 times negative 5 is negative 15. Now I can simplify. The left side is fully simplified. The 8x and the 4 can't combine. But on the right side, we could simplify the 29 minus 15. 29 minus 15 would be just 14 plus 6x. And at this point, when we recognize that I've got x's on both sides of the expression, my goal is to get all the x's to one side, all the numbers to the other. Why don't you pause the video and solve this equation? Unpause to check your work. So I'm going to move the 6x because it's smaller. That would result in still a positive amount of x. It's currently positive, so I'll subtract from both sides. Cancels it perfectly on the right side, and on the left side we would be left with 8x minus 6x's is 2x. Plus 4 equals 14. Now we can solve for this, so we would get 2x plus 4 equals 14. We would subtract a 4 from both sides because it's currently positive, so we do the opposite. That would leave us with just a 2x equals 14 minus 4 is 10. To get x by itself, it's currently being multiplied by 2, so we do the opposite and we divide both sides by 2. And that would give us x should be equal to 5. Now let's verify our answer. I'm going to plug 5 back into the original expression and see if I get the same on both sides. 4 times 2 times 5 plus 1 is that equal to 29 plus 3 times 2 times 5. Now 2 times 5 is 10, plus 1 is 11, so that's going to be 4 times 11 equivalently on the left side. Is that equal to 29 plus, 3 times 2 times 5 is 10, minus 5 is a resulting 5. 4 times 11 is 44. Is that equal to 29 plus 15? 29 plus 15 is indeed 44. So we get both sides are truly equal to each other, which means we can be sure that we had the correct answer, because if you plug in 5 to the expression, you do get 2 equal values. Now in our next example, we see it's an equation, but one thing that we'd probably note is that we have fractions. And whenever we're solving equations, we do not want to keep and deal with the fractions. The fractions would make the problem more complicated. So your first goal, whenever you recognize the problem has fractions, is to multiply by the least common multiple of the denominators. Denominators are just the numbers in the bottom of the fraction. Now this is good news because we learned how to find the least common multiple. The least common multiple of 2 and 6 is going to be, or 2 and 3 is 6. So each side is going to be multiplied by 6, and we can do this because as long as you do the same thing to both sides, you're still keeping the expression equal. One thing to note here, the left side has multiple terms, so it's important that I leave them in parentheses as I multiply by the 6 to ensure that this gets distributed to both pieces. Now 6 times 2x divided by 3, the way you're going to visualize this is 6 is the same as 6 over 1. Multiplying fractions, 6 times 2x would give us a 12x. 1 times 3 keeps us at 3. Now 6 times 7 is 42, minus 6x over 2. And both of these can be simplified. It still looks like we have a fraction, but if you type 12 divided by 3 in your calculator, you would get exactly 4. So that's really 4x's equals 42 minus 6 divided by 2 is 3x's. Okay, so we'll solve for x. Currently I have a negative 3x, so it might be most efficient to add a 3x to both sides, do the opposite. That would give me 7x's equals 42. So to get x by itself, it's currently being multiplied by 7, so we divide 7 from both sides. 42 divided by 7 is 6. Now we do need to check our work. Let's plug 6 into both sides of the expressions and see if we get a true statement. So 2 times 6 divided by 3, is that equal to 7 minus 6 divided by 2? Let's simplify both sides and see. Now 2 times 6 is 12, divide that by 3. 7 minus 6 divided by 2 is 3. Now that would simplify to 12 divided by 3 is 4. 7 minus 3 is also 4. So it does work out. We can be confident that 6 is the right answer, because when we plug 6 into both pieces of the expression, we get equal statements. Next comes the idea of proportions. Now, a proportion is just a statement, in this case a statement that involves an equal sign, that says two ratios should be seen as fractions, are equal. So, for example, we could have 10 over 2 equals 5 over 1. This is the example of a proportion. And we can be sure that it's equal because 10 over 2 is 5. 5 over 1 is 5. Another way you can check, perhaps you've heard this phrase before, is cross multiply. If you take the bottom of 1 and multiply it by the opposite top, that should be equivalent in value to the same thing with the other terms. So if we want to verify that and we cross multiply, 10 times 1 is 10, 2 times 5 is 10. If these are equal, that verifies the proportion is true. Let's now solve some equations involving proportions. So here we have one fraction, 10 over x equals 2 over 3. There's two ways to solve that. Let's go through the cross multiply method first. That would mean that you take 2 times x and set that equal to 10 times 3. Now 2 times x is 2x, 10 times 3 is 30. So I would simplify to 30 equals 2x. Again, 10 times 3 for 30, x times 2x for 2x. Now at this point the 2 is being multiplied, so we can divide both sides by 2, and we would get x has to be 15. Now let's verify if we want to check this. We're going to substitute that back in the original expression and see if we get a true statement. 10 divided by 15, is that equal to 2/3? Well, this really comes down to checking, can you reduce a fraction to its lowest terms, like we've done before. 10 is 2 times 5. 15 is 3 times 5. Whenever you have the same thing above and below, it does cancel. And indeed, we would get that it's equal to 2/3. So if you've got an equation involving proportions, just remember to cross multiply. Next, we're going to see when is 22 divided by 60 minus x equivalent in value to 2x. And as it's currently written, we don't want to deal with the problem when there's fractions there. That's going to make it difficult to solve. So we'll do our cross multiply method. 22 times x, set that equal to 2 times 60 minus x. 22 times x is 22x equals, now since there's two terms here, I'm going to make sure I offset it in parentheses, 2 times 60 minus x, and that way I'm going to distribute the 2 to both sides. That would simplify to 120 minus 2x equals 22x. So we will add 2x to both sides to get x's by itself. (24x) equals 120. Since we're being multiplied by 24, we can divide both sides by 24. 120 divided by 24 would give us 5 exactly. So x should be equal to 5. And then we do have to check our answer. Everywhere there's an x, let's plug in a 5. So 60 minus 5. Is that equal to 2 divided by 5? Now 60 minus 5 is 55, so this would become 22 over 55. Is that equal to 2 over 5? And this would be the case because 2 times 11 is 22, 5 times 11 is 55, so if we think about our reducing to our lowest terms like we did before with our fractions, we see that 22 over 55 is indeed 2/5. So we found the value that makes the equation true, and our solution is x is equal to 5. Next, we're going to solve some word problems involving proportions. Let's read our first example. The property tax on a house with an assessed value of $250,000 is $3,500. Determine the property tax with an assessed value of $420,000, so a more expensive house, assuming the same tax rate. Now when it says assuming the same tax rate, that means that the cost per house is proportional to the property tax. And if two things are proportional, then we can set up a proportion that relates the ideas. So for instance, let's consider the cost of house as a proportion divided by its property tax. With that in mind, we can set up the equation. For the first expression, we know both the cost of the house and the property tax. So that would be for the cost of the house of $250,000 divided by the property tax of $3,500 should be equal to, and now we're going to try to match this with the more expensive house. But in the more expensive house, we only know that the cost is $420,000. We do not know the property tax, so let's call that X. So we have set up a proportion, and we can solve this proportion as before by cross-multiplying and solving for X. Here we'll definitely want our calculator, so 250,000 times X would be 250,000 X. Now 3,500 times 420,000 would be equal to this number. And now if we want to solve for X, it's currently being multiplied by 250,000. So we would divide both sides by 250,000. And we get that the property tax for the more expensive property should be $5,880. So that'd be our answer there. So remember, when you've got two ideas that are expressed by the same rate, that means we can set up a proportion. And what you do is you just think about what quantity do I want at the top of the proportion, what do I want at the bottom, and then follow that pattern for both items. Cost of house was top in both sides of the proportion. Property tax was at the bottom in both sides. Now next we have a similar proportion problem. I recommend that you take a moment to pause the video, read through it, and then solve it on your own. It is a proportion problem. And when you've solved it, unpause to check your work. So we're told that wildlife biologists catch and tag deer, and then they had 120 at first, and they released that into a refuge. 2 weeks later, they have a sample of 150 deer, and 25 of them have tags. Assuming the ratio of tagged deer holds for all the deer in the refuge, so by this statement, we know that we can set up a proportion. They're asking us to find how many deer are in the refuge. Now, the way we're going to think about that is there were 120 tagged deer in all, and in this representative herd, we saw 25 of them, and the representative herd had this size. So that should be proportional. So let's compare herd size to tagged animals. So we have two fractions to set up. We know everything in this sample. We know that the herd size that we saw there was 150, and out of those 25 were tagged. Now we don't know the herd size of the entire refuge. That's what we're trying to find, so that's going to be our X. But we do know that there are 120 tagged animals in the entire herd. Once we set up this proportion, we can cross-multiply to get an equation. 150 times 120 would be 18,000. 25 times X is 25X. So we can solve for X if we divide both sides by 25. So that tells us the herd of the entire refuge size is 720 deer. Now the last thing we want to consider in this section is what happens whenever we solve an equation and we end up getting a false or a true statement at the end. we no longer get like x equals a number. Instead, we get something like 2 equals 2 or 2 equals 5. There are certain conclusions we draw from that case. Now, if we were going to distribute this, we'd want to solve the equation, but first we have to make sure both sides are simplified before we start to algebraically move things. The left side is simplified, but the right side we needed to distribute the 3x plus the 3. Now I know if there's x's on either side, my goal is to get all the x's to one side, so I'm going to move the 3x. It's currently positive, so I'm going to subtract. Now my goal was to get rid of the x's here, but since there was the same amount of x's on the other side, 3x minus 3x would leave us with 0 x's, or 0. So we would just be left with the statement 7 equals 3. Now 7 is not equal to 3. This is a false statement. Now we haven't done anything wrong. We went through the process correctly. But if you're solving an equation and at the end you get down to a false statement, what that means is there's no solution. That means that these two equations should have never been set equal to each other. There's no x value where 3 times x plus 7 is equal to 3 times x plus 1. So up until this point, you probably have not seen this occur because all the problems you were shown were specially chosen to have a solution. But you can't just set two expressions equal to each other all the time and hope that they have a solution. So how do you recognize no solution? When you get down to a false statement. Take a moment to simplify and solve for the next equation. I recommend you pause the video, work till you get to the end, and then unpause to check your work and hear the discussion about how we would interpret its conclusion. Before I can solve for x, I do need to simplify the right side, so 9x plus 9 minus 2x. 9x minus 2x would be a 7x. So when I try to solve for x, I'm going to move all the x's to one side, numbers to the other. So I move a 7x over first. It cancels from the right side, but since it's equal in value to the left, it also happens to cancel there. 7x minus 7x. That would leave us with 9 equals 9. Now, unlike before, this is a true statement. 9 is equal to 9. 7 was not equal to 3, but 9 is equal to 9. So the conclusion, when you get a true statement, that means there's infinitely many solutions. And that would be your conclusion. So if you're solving an equation and you get x equals a number, that's your solution. Check it and you can verify it's correct. If instead when you're solving, you get down to something that's an arguably false statement, like 7 equals 3, that means the equation has no solution. And if you're solving the equation and you get down to a true statement, that means that there are infinitely many solutions. Remember, we do have homework from the textbook following this section. All the answers are odd, so you can do each problem, check your answer in the back of the book, and then if you got it correct, go to the next problem. If you didn't get it correct, remember you're always encouraged to seek help via Canvas message or meet me in virtual office hours.